Welcome to Mr. Frolic's physics classes. In today's lesson, we will talk about an introduction to one-dimensional motion.
Hi there. In today's lesson, we're going to do a quick introduction to some basic concepts of one-dimensional kinematics or just kinematics. Kinematics is just a description of motion. What we're going to discuss now here is how to describe objects as they move. So to start understanding our situation, let's imagine this here. So let's say that my first character, particle boy, with his baseball cap, A, is located at a pizza shop. And his friend, particle girl, B, is located at an ice cream store, ice cream parlor. And I want now to talk about their positions. So the first thing we're going to talk about in this sense is the definition of position. And it only makes sense to talk about position if we refer that to a reference point, to a perspective, to a point of view. So let's say that in here I'm going to use this point as my reference point. And I'm going to call this point here 0. In physics, we usually use a 0 point. The reference point is usually O for origin, or in a mathematical symbol, 0. Now let's say that the ice cream place is 5 meters away from the origin, and the pizza place is also 5 meters away from the origin. With these values, we would say that his position, and we often represent position by x, his position, x index A, is 5 meters, and her position, x index B, is 5 meters. But an observer looking only at this information here would be led to believe that they are in the same spot, that the two are side by side. And well, they're not. So I need to distinguish these two positions. And in physics, the way we do this is by assigning a mathematical symbol to represent direction. So for example, I'm going to stretch this to the left a little bit more. X in meters, and I'm going to call positive to the left. And in that sense, his position is plus 5 meters, which is 5 meters from the origin in the positive direction. Her position is negative 5 meters, which is 5 meters in the opposite direction of the positive direction. Okay? So basically that's the concept of position. Let's now talk about the concept of distance traveled. So he's at the pizza place, he pulls up his phone and tells her, B, I am here at the pizza, let's come and eat some pizza. And then she replies back to him, oh, A, I'm at ice cream. Let's have some ice cream first. And then they are discussing who should go where. Notice that if he goes to the ice cream shop, this being his initial position, and we often represent this initial position by x index 0, x naught. So if he goes this way and ends here, the distance he's going to travel is 10 meters. But let's say that actually he was more persuasive and he convinces her to go from the ice cream to the pizza place. This is her initial position, x naught of b, and she'll be traveling to this point here, x final b. And the distance she'll travel is also going to be 10 meters. X naught a, and then x final a. And that's right. I mean, if he walks towards her, she walks towards him, the distance traveled will be the same. But the outcome is not the same. And then we need to define a new quantity to also account for this idea of starting point and ending point and the direction you're actually moving. So we then will define displacement. So displacement, we represent, or change in position, we represent by the symbol delta x. So delta represents change. It's an operator in science, represents change. And it's always defined as final minus initial. So delta x is always going to be x final minus x initial. Final position minus initial position. So for A, his displacement is going to be his final position, negative 5 meters, minus his initial position, 5 meters. So his displacement is negative 10 meters. And we need to understand this as negative 10 meters being he walked 10 meters, but in the negative direction. Her displacement is going to be different. Her initial position was negative 5, and her final position was 5. So her displacement is going to be 5 minus negative 5. And then that comes out to be 10 meters, because negative with negative becomes a plus. In this displacement information, I see how far they are at the end as compared to the starting point, and the difference in directions. And you see that if she convinces him, they will have ice cream. If he convinces her, they'll eat pizza. The outcome is going to be different. Now, there is no better tool. Some people sometimes ask, but what is better, distance or displacement? And I would say these are just tools. What you need to do is just see what is at that moment that you want to know. So if I'm talking about, for example, running laps around the field, or I'm going to be exercising, distance is the best tool, because my displacement after running several laps and stopping at the same spot is going to be 0. But then that's a situation where my distance traveled matters more. For displacement, let's say in an American football game in which the ball starts at a certain point and they need to advance the ball. It does not matter how much they run back and forth with the ball. It matters is that the player needs to end X meters ahead of the starting point. And that's a situation where, for example, displacement is a better tool. So let's now talk about speed and velocity. Let's say that she convinced him to have ice cream. So at a time equals to 0 seconds, he will start walking from his initial position towards her. But he decides to first buy her a gift. So he's going to go, let's say, 5 to here. He's going to walk to the gift shop. And let's say that he arrives at the gift shop at a time of 4 seconds. 2 seconds later, they're really fast in here, quick service. He's leaving the gift shop. And then he walks, and now because he's carrying a big gift for her, maybe a big stuff, maybe a big teddy bear, you know, he arrives in here in 10 seconds. And then we want to know his average speed and average velocity in this process. So average speed is, by definition, distance over time. So he traveled a total distance of 5 plus 20, 25 meters, plus another distance of 20 to 5, negative 20, negative 5, 15 meters. And it took him a total time of 10 seconds to do this. So my speed average is going to be 40 over 10, which is 4 meters per second. Couple things here to note. Number one, distance is always positive. So it does not matter if it's going one way or the other, I'm always adding. The same way that as I'm walking and I have my Fitbit or whatever measuring how many steps I do, it does not matter which direction I'm moving back and forth, it's just always adding steps. Another thing is, it does not matter for me if I stopped or not. When I'm taking an average value, I just want to know the total length of time and the total distance. The time stopped does not count in this sense. And so this means that as he was going from his house, from the pizza place to the gift shop, back to the ice cream place, he was moving on average 4 meters for every 1 second. Now, average velocity is defined as change in position over change in time. So it's going to be delta x over delta t. Notice that in here now, his final position is negative 5 meters. And his initial position was 5 meters. The time is the same as before, 10 seconds. So his average velocity is going to be then negative 10 over 10, negative 1 meter per second. His average velocity, negative 1 meters per second, tells me just that while he was going from pizza place to ice cream shop, his position changed on average 1 meter every second in the negative direction. Okay? Now maybe in this situation, average velocity would not have been the best tool. Average speed would have been the best tool. Maybe not. Again, speed and velocity are different tools that we use in different situations.